It all came to bear at this moment. The name of that project, General Robotics 003.
NVIDIA's GROOT N1 humanoid robot, built in collaboration with DeepMind and Disney Research, isn't science fiction. It's already walking among us. Not on movie sets or lab floors, but in real-world simulations that mirror our homes, factories, and public spaces. GROOT N1 represents a bold leap into general-purpose robotics, blending intelligence, movement, and real-time decision-making like never before. This isn't just another metal machine on wheels. This is a humanoid robot, trained not just to follow commands, but to learn from its surroundings, to adapt like humans do, and to eventually become part of the world's workforce. That might sound like a big claim, but NVIDIA, along with DeepMind and Disney Research, is backing it up with some serious brainpower, cutting-edge tools, and a powerful vision. So how did we get to this point? And what makes GROOT N1 so different from the robotic arms and factory machines we've seen before? The journey starts with a simple, yet massive global problem. There just aren't enough people to do the work that needs to be done. As the world pushes toward more production, more services, and more connected systems, there's a growing shortage of human workers. Estimates say that by the end of this decade, there could be a shortfall of over 50 million workers globally. That's the kind of crisis that forces innovation, and the answer is starting to look a lot like general-purpose robots. Robots that don't just stand in a corner and weld metal. Robots that move through real environments, think in real time, respond to touch, and learn as they go. These robots are designed to understand the world the way people do, but with the tireless strength and endurance of machines. That's the idea behind general robotics, and NVIDIA's GROOT N1 is one of the most ambitious steps in that direction. Robots that can navigate chaos, adapt to unexpected obstacles, and still complete tasks with precision. Machines that don't just follow scripts, but reason through problems like living agents. GROOT N1 isn't programmed for one job. It's trained for endless possibilities across industries. It's not just automation, it's autonomy backed by intelligence that evolves with every interaction. And in a world where flexibility is key, this kind of learning robot could become the backbone of next-gen infrastructure. Now, what makes GROOT N1 so special? It's not just about looking humanoid. It's about being smart, adaptable, and deeply connected to a digital backbone that allows it to keep learning every second. At the core of this robot is a system built to interact with the physical world in ways never seen before in commercial robots. This means being able to move in complex environments, make real-time decisions, and perform delicate tasks that require not just force, but finesse. But how does a robot like that even learn to do these things? That's where the real magic begins. One of the biggest challenges in robotics is training. Getting a robot to understand not just what to do, but how to do it in ever-changing conditions. To tackle this, NVIDIA built a foundation known as Omniverse, an operating system for what's being called physical AI. It's essentially a simulation world where robots like GROOT N1 can experience billions of scenarios without ever stepping foot into the real world. Inside Omniverse, NVIDIA added something extraordinary: Cosmos. Think of Cosmos as a generative AI system that can create infinite training environments. These aren't just random setups, they're controlled, grounded, and endlessly varied. This allows GROOT N1 to train in 1,000 different kitchens, warehouses, or factories in just hours. It's like giving the robot a lifetime of experience before it even touches a physical object. And the robot doesn't just watch and learn, it feels. One of the most important innovations here is in how GROOT N1 handles tactile feedback. That's the sense of touch, and it's something most robots have struggled with for years. They can detect force, sure, but actually feeling when to grip tightly, when to hold gently, or how to balance soft and rigid materials. That's a whole new level. To enable this, NVIDIA developed a physics engine called Newton, and they didn't do it alone. This is where the collaboration with DeepMind and Disney Research comes in. These are two of the most forward-thinking teams in AI and robotics. DeepMind brings unparalleled expertise in reinforcement learning, where robots learn by trial, error, and rewards. Disney Research, meanwhile, knows a thing or two about expressive movement and character dynamics, especially in entertainment robotics. When these forces combine, the result is a physics engine that isn't just about simulating gravity. It's about recreating the tiny, real-world sensations that make movement believable and effective. So imagine this. GROOT N1 is in a simulated kitchen in Omniverse, guided by Cosmos, running thousands of simulations through the Newton physics engine. Every movement it makes is tested, rewarded, and adjusted, just like a child learning to walk or play. And here's the impressive part. It learns all this without risking a single scratch in the real world. Then, when it finally operates outside the simulation, it's already smarter, more coordinated, and more capable than most would expect. And this isn't just theory. NVIDIA showcased these capabilities with two small robots.
This is orange, and this is the famous green. They are the BDX robots of Disney.
Orange and Green, from Disney Research. These robots were trained inside Isaac Sim, another crucial tool that connects NVIDIA's simulation platform with real-world robotic systems. What powers these little characters? Jetson, NVIDIA's compact AI computers designed for robots. It's these same Jetson modules that power much of the intelligence inside GROOT N1. Now, it's not every day you see cartoonish-looking bots become the stepping stone for a robotics revolution. But when those robots are trained in the same environment and with the same AI systems as GROOT N1, it becomes clear that this is more than entertainment. It's a scalable, learnable, replicable process. Whether it's a humanoid robot helping in disaster relief or a small assistant in a theme park, the same tools can apply. Here's a question to think about. What happens when these robots become so smart and so affordable that companies begin hiring them at scale? The reality is that might not be far off. NVIDIA's CEO even hinted that businesses might be paying humanoid robots a salary, just like human workers. And with the projected labor shortage looming, this isn't a backup plan anymore. It's a growing necessity. But it's not just about replacing humans. It's about building infrastructure for robots to thrive. NVIDIA isn't stopping with just one robot or one model. The larger vision includes building AI infrastructure across 3 levels: for the cloud, for enterprise, and now for physical agents. GROOT N1 is the first serious step in making AI-powered robots part of everyday operations across industries. Another question to ask is, can these robots become part of our daily lives without feeling cold or mechanical? Disney's involvement might be the secret ingredient here. Their deep knowledge in making characters feel alive through motion, personality, and subtle interaction is now feeding into how robots like GROOT N1 move and behave. It's not just about utility anymore, it's about connection. So where does this all go next? NVIDIA has already open-sourced GROOT N1, allowing developers, researchers, and roboticists around the world to contribute and improve the platform. This means faster innovation, more diversity in robot design, and a growing ecosystem of AI-driven machines. And with Omniverse, Cosmos, Newton, and Jetson working together, the learning curve keeps accelerating. Imagine warehouses where robots coordinate without crashing into each other, kitchens where assistants prep meals alongside humans, and cities where physical AI can respond to real-time emergencies faster than human responders. This isn't a fantasy, it's where NVIDIA is steering the future. And all of this is happening not in 2050, but right now. The simulation is real, the robots are here, and GROOT N1 is walking proof of a future that blends intelligence, emotion, and action into a single seamless agent. So the next time someone says robots are coming for our jobs, the better question might be, what if they come to work with us instead? This is just the beginning. GROOT N1 is more than a humanoid robot. It's the front line of a revolution that combines data, simulation, physics, and real-time intelligence. With DeepMind, Disney, and NVIDIA working in sync, there's a new kind of collaboration unfolding, one that's not just reshaping robots, but rewriting the relationship between humans and machines. And if this is what the first open-sourced version looks like, imagine where the next generation will go. Smarter, faster, more responsive, and trained in digital worlds that mirror our own. The age of physical AI is here, and it's wearing the face of GROOT. GROOT N1 isn't just another robotics prototype. It's a window into a near future powered by AI that sees, feels, learns, and adapts in the real world. Built on a simulation-first foundation with NVIDIA's Omniverse, trained in infinite digital realities by Cosmos, refined by the hyper-accurate Newton engine. If the future of AI-powered robots excites you, don't forget to hit that like button, subscribe to the channel for more deep tech breakdowns, and drop a comment below. What would you want a humanoid robot to do in your everyday life? Let's talk in the comments.